Welcome to the ET380 pin diode lab. Okay, here's our circuit that we built in Multisim, and here is our pin diode, and let's go ahead and activate our Multisim. Okay, let's start our Multisim for our pin diode circuit here. Let's turn it on, open up our scope, and spread this out. And this is our input signal. Okay, and let's turn on our second channel, and we have nothing. Okay, and a pin diode, this is going to be a high frequency switch. So let's go ahead and close our switch. And let's go ahead and make them both 2 volts so we can squeeze them all in there. Come on. And let's move him down. And let's make channel 2 2 volts. And we see them both there. They're in phase. And let's go ahead and check our frequency. Let's go to measure. Hundred kilohertz. Let's open up channel 2. Let's go down here. Channel 2. Frequency, and they're both the same frequency. And let's just check and see if the voltage is the same. So we're going to channel 1, peak to peak. 4 volts, more or less, and 4 volts. So we have the same signal. So let's just go ahead. I'm going to go ahead and open the switch and close the switch. And we have a high frequency switch. Let's do a single sequence. Okay, here's our close-up of our oscilloscope showing that we have in-phase signals and identical signals. Here's our pin diode circuit, and we've duplicated essentially the same circuit with the exception of the function generator. So let's go ahead and open up our Multisim file that we built. Okay, let's get started with our second circuit here. First off, let me get this guy out of the way here. I put him in the wrong place. There we go. So let's hook up our input to our first circuit, output to our first circuit, and let's go to the input to our second circuit, and output. Start our, first off, let's go ahead and let's change this guy to A so that we don't operate at the same time. Let's go ahead and start it, and let's open up our switches here. So switch and A, both switches are open. Let's open up our scope. Okay, so there is our first input. So let's make him 2 volts at least. There we go. Spread it out. Good. Let's make him 5 volts. Okay, so that's our input. And let's turn on channel 2, and he's flat. Okay. And let's open up our switch. Or closer. Okay, and let's close our switch, sorry. And let's go ahead and make him 5 volts also. And so that circuit is on now. In phase, everything's the same. So let's go ahead and turn them off. Okay, let's turn him off. Let's take a look at our input from our second circuit. And let's see what is going on there. We have okay, let's turn, okay, that's the input signal. Correct. And let's turn on our last channel. And close switch A. Switch A. And let's try triggering off of channel 3. There we go, that's much better. And let's make him 5 volts. Get 5 volts, make it stick. There we go. And it did not stick. There we go. All right, so here we have our circuits. And let's go ahead and hit A again, and it should turn it off. And it does. And let's go ahead and close our first switch. Turns on. Let's hit our second switch, and he turned on. So we have a high frequency switches in our 2 circuits. Okay, I've cleaned up my scope. So here we have, let's go ahead and do a single sequence. And we see that we have 2 matching signals with both on. So let's go ahead and, just for clarification, let's go ahead and get our space bar, get it running again. There we go. Turn off our first circuit and turn off our second circuit. Okay, here's a close-up of our oscilloscope with both switches closed, showing our circuits that are operating as a closed switch. And here's a close-up of our oscilloscope with our switches open, showing the pin diodes acting as a open switch. So our circuit is off.